Hello everybody and welcome to the E5 podcast. In this episode we're going to delve quite deeply into the dark and hidden mysteries of Chapter 13. Chapter 13 in BS 7671, commonly known as the IET wiring regulations, is entitled Fundamental Principles, and it's fairly evident that those fundamental principles sometimes can get forgotten over time. They get lost in the ether of just busy jobbing spark, busy contractor, busy fault finder, busy tester, busy inspector, busy project engineer, whatever role you work in the electrical industry. And I thought I'd just take some time out to record this to kind of just refresh Chapter 13, but a specific part of it, because we'll probably cover the rest of Chapter 13 in another podcast with the lads. So I'm on by myself tonight. So we're going to delve straight into it. Now, Chapter 13 of the wiring regulations has a number of clauses. One of them being obviously the no alterations or additions clause, which tells you very succinctly, don't alter or add to an electrical installation unless you ascertain and verify that the kit isn't knackered, that the installation can take it, and is actually suitable with sufficient earthing and bonding. Now, they're not exact words, but I'm sure you can read that section for yourself, and we'll cover it in another podcast. But there's also the good workmanship and materials regulation towards the end, which is critical because it talks about skilled and instructed persons, and it talks about the competency of the person testing the work. But one of the other things that it covers, and it kind of really gripes me, is design, which is section 132, so it's slap bang in the middle of this chapter. And there are 3 regulations alone that actually state that we should be considering external influences. Now, if you head over to our Instagram page, you'll see lots and lots of pictures of heavily corroded installations. Now, I can tell you now that some of those pictures are from installations that are 5 or 6 years old. So we as Sparks are installing galv trunking, metal trunking, all sorts in all sorts of locations. Now, generally, if it's an inside an enclosed building, you don't have to worry too much about external influences. The only real things you have to worry about on a new site is, alkalines and porous walls from freshly poured concrete, but that's generally mitigated by Unistrut, which you could also consider what is known as a sacrificial anode. So Unistrut isn't just for fixing, but it also, if there is a porous or alkalining surface, it acts like a sacrificial part of the cable management, and it will corrode first, so that upon maintenance and inspections you can actually see where you have to go up and renew, and you can also see that if there's any leaks in the walls or any other harmful things, it could damage the long-term installation. Now, if I take you through the journey of the Big Blue Book while you're driving, or probably falling asleep actually listen to this, maybe I should just talk slower. No, Regulation 13251, and it states the design of the installation shall take into account the environmental conditions to which it will be subjected. I mean, seriously, that's it. It's black and white. It's really, really bloody easy to understand that. You will take into account environmental conditions to which you'll be subjected. How many people think about that when they're doing the design? Now, not a lot. And for the guys who don't do design and just do the install, they kind of switch off. I mean, having come up as an industrial spark to start with, you do switch off. You're just like, what does the job spec say? Oh, a 3 compartment, 300 by 150 trunking. Right, let's just throw it in. And it's out in the open air, and you're not thinking sometimes. You just don't, because sometimes you're not paid enough to. Sometimes you just, you try and tell people and nobody listens. But the fact of the matter is the wiring regulations, at the end of the job, you may get a client turn around to you and say, right, that section of departures on the certificate, where is your departure from every single clause? Now, anyone who knows me, I expect a separate list of departure of clauses, which generally freaks the designers out. but it's true. So regulation 13251, the design shall take into account the environmental conditions. If somebody else is doing the design, how have they documented and defined what the environmental conditions are? Or as a client, have you told your contractors what the environmental conditions? I work on the railways. I'm actually defining in my scopes of work what the external influences are for the designer to consider. Now that leads you on to a section of the book right at the back that most people, when they go to the back of the book, they're looking at time current curves, or they're looking at current carrying capacity of armoured and singles, clip direct, but they're not looking at a section called Appendix 5. Now Appendix 5 is really interesting because Appendix 5 effectively it basically covers all of the external influences really well. And it gives you all of your codes, and then it also explains more and more about those codes so that you can understand them. And it breaks down a concise list of external influences, the biggest part being environmental, the next part being the utilization of the installation, and then the last part, buildings. So for instance, let's look at corrosion, electromagnetic fields, which is an AM9, DC current in AC voltage, AM7, very much prolific now with all the DC equipment we have, PV, EV, voltage unbalance, voltage amplitude, signaling voltage, very much railway, flora and fauna, AK and AL, vibration. How many people consider vibration? Serrated washers, spring washers, penny washers when they're doing industrial fit out. What if you're doing a block of flats that's next to a railway or next to a construction site? Is it worthwhile doing something that bites down and actually protects against vibration? So there's 3 codes there for low, medium and high. Impact, known as IK ratings. IK is very similar to IP, IP being ingress protection of water. IK is impact protection against direct impact from somebody punching or kicking or even hitting with a baseball bat. And that goes up to IK10, although a lot of manufacturers, including lighting, they tend to go above IK10. So there's foreign bodies, so it covers wind, movement of air, lightning, seismic, solar, UV radiation, lots and lots of environmental conditions. Now what it does, being the wiring regulations, it gives you explanatory information where it can, with the exception of AM7, which for nearly 15 years has just took you on a wild goose chase, referring to a regulation that doesn't exist in a section that is empty. So that straight away tells you that the wiring regulations, whilst they are a guidance note, are not the definitive one-stop shop for the answers to your design solutions. So this is why we in E5, the guys, we always say you must work from the regulations. If you're arguing over a regulation, something must be going wrong at the management, the design, the procurement level. So we'll try and work from the wiring regulations. Now, if we look at these wiring regulations in any great detail and the external influences, I've just said to you 13251, which says the design of the electrical installation shall take into account the environmental condition to which it will be subjected. Plenty of information in Appendix 5. But then it says Regulation 132.7, so it's a little further on. And it says, again, the choice and type of wiring and the method of installation shall include consideration of the following: nature of structure, accessibility of persons, voltage, electromagnetic stresses, electromagnetic interference, other external influences, fire, thermal, solar, vibration, mechanical, flora. So it's basically repeating it, it's breaking it down again. So you've got 2 regulations straight away that are basically saying the same thing. But hey, hang on 1 second. Let's go to another regulation. This is all in Chapter 13. Regulation 133.3 states, electrical equipment shall be selected so as to withstand safely the stresses, the environmental condition and characteristics of its location. Guys, girls, it's the same thing 3 times over. Consider the external influences when you're undertaking your design, when you're trying to protect for safety. It's absolutely incredible and imperative that you do that. Now, a lot of people are installing stuff, and we all know there are a lot of guys and girls out there listening that go around on mop-up duty. And that's all they do, is they literally will go around buildings that have just finished, projects that have just finished, spending months, maybe years, rewiring, redoing, seeing poor designs, poor install, having to fix it. Whereas if we can try and get these fundamental principles into our head, then it hopefully will allow you, regardless of what role you're in, to maybe influence the designers and save the projects you're on money. Because at the end of the day, this all comes back to taxpayers. And one way or another, every single one of us are a taxpayer. So we look at the external influences, and now what we do is we'll have a look at some of them which are very prevalent. So cable management, we all know cable management, we all stick galv trunking and conduit everywhere. Now, is that the right thing to do? Well, depends. So who here has heard of BSEN 60068-2-11, and it's called Environmental Testing Test Method, Test KA Salt Mist, and it's a neutral salt spray test, which is in that standard, and it's about the resistance to sea salt mist and enhanced temperature. And how many people have actually looked at that standard? Probably not a lot. There's also a standard, BSEN ISO 12944, paints and varnishes, corrosion protection of steel structures, bioprotective paint systems. Now that defines environments for methods of protection for corrosive steelwork, but that also includes how you would select and erect your conduit systems. So if we then look at the codes for corrosion, if we then look at AF code, AF is presence of corrosive or polluting substances. Now if we look at atmospheric, it says the presence of corrosive or polluting substances of atmospheric origin is significant. Installations situated by the sea or near industrial zones producing serious atmospheric pollution such as chemical works, cement works, and then there's a bit that says according to the nature of substances, satisfaction of salt mist test according to BSEN 600682-11. So straight away that's referencing you must choose the right protective measure for your electrical installation to protect against atmospheric corrosion. We live on an island. We're surrounded by the sea. You know, everything has a level of salt mist in it. And believe it or not, Network Rail in the railways, they've actually got great methods for determining what paint and treatment systems they need to use. But there's also some rules of fun which we'll cover in a second. Other bits, AG codes, mechanical impact, well we know that from the IK ratings, vibration, AH1, low severity, domestic, medium severity, industrial compounds, you know, severe vibration, machinery, stuff like that. What are we doing to protect against that? If we then go on to the AM codes, which there is one called AM7, direct current in an AC network, and it refers to regulation 321-1017. So when you get a chance, go and look in your book and you'll see it's completely blank. This mistake has been in this book for nearly 15 years. So there is no guidance yet on DC current in an AC network, which is why I think DC is about to ramp up quite a lot within domestic installations. But it states in the characteristics required, you will take measures to limit their presence and level and time in current using equipment or their vicinity. No guidance whatsoever as to how to do that. We then move on into the AM codes, electric fields, and then again refers to lots of BSEN standards. Should be looking at it. Are you looking as a designer? Are you looking at it as an electrical installer? Solar radiation? Are we looking at UV degradation, lighting, movement of air? There's also then the capability of persons. Small children. There was a case where a child died climbing over a fence and grabbed the light. Poor soul got electrocuted. Do you understand, if you're managing these installations, what the external influences are? Do you have any guidance note or procedures where you're instructing your supply chain? This is what I expect you to mitigate or design for. In a domestic installation, the AM7 one is definitely prevalent, but also when you're wiring to sheds and external, are you looking at all the different external influences? Now, if you look, if you can afford to buy it, BSEN ISO 12944, it defines the following environments in relation to corrosion as C1, C2, C3, C4, C5L and C5M. And it goes from very low heated buildings such as offices and shops to low Low atmosphere contaminated to a small extent, small rural regions. Buildings which are not heated, condensation. Medium, most rural and urban areas with sulfur dioxide, acid, alkaline. C4, high chemical plants, swimming pools, marinas. C5L, high industrial areas, aggressive atmospheres. And then C5M, very high marine, inshore and offshore areas of high salinity. Now straight away, if you take a railway, because again I'm using my experience here, most railways that go around the coast, my route in particular, it's most certainly a C3 to a C5. It's a marine inshore area. So if I start selecting and erecting galv trunking, I'm failing. I'm failing before I've started putting it on the wall. Because if I'm putting it out on an open platform, it will corrode. Now, columns are galvanized, but the thickness of the galvanized coating protects it sufficiently. There is a different thickness of coating on galv trunking, which is why it will rot and corrode. And of course, the minute you cut it and damage it, you're exposing it to salt mist deposits and all those alkaline contaminants in the air and the salinity of the wall, you're starting to corrode it straight away. So when you're selecting and erecting this, Appendix 5 is a guide, but more importantly, if you're an engineer or a spark who's trying to work your way up through the chain, this is the kind of thing you do to demonstrate knowledge to your employers, to show them, actually, I know what I'm doing. I can be of use to protect the budget on this job. I can save you money. Yes, you'll probably be deemed a troublemaking little git, but if you say it in the right way in front of people, you won't be. You'll actually be seen as a value-added person. Also, that can lead to promotion if you're trying to get off the tools. Now, just taking those 3 regulations and that other ISO, BSEN ISO 12944, straight away you can probably realise there's some common rules you can follow. So this is my professional engineering judgment, but for me, galvanised is fine anywhere you like, with the exception of generally within a mile from anywhere from the coast. So if you're working anywhere Docklands way and it's out in the open, you will be using a grade of stainless steel. Personally, I go with stainless 316 because it has less pitting in the surface and will last longer. And if you can't afford stainless, because the minute you say stainless, everybody has a heart attack, go with GRP. The technology is good for GRP now. Go with GRP. But the minute you get into a sealed building, you can change that back to galv, because it's less polluted, contaminated environment, it's less aggressive, but that in itself is good design, selection and erection of electrical installations. Now, in case you're wondering, well, it's all a guidance note, don't worry about it. Please don't forget that the wiring regulations can be used to prosecute in a court of law. They'll be used as evidence. Now, if you happen to install a galvanized system of conduits, for instance, 2 years later or even 12 months later, there's a bimetallic corrosion onto a beam and the conduit saddle fails and it takes down a whole load of stuff. Within 12 months, you're the builder, the contractor, the courts are going to come after you and you're going to get asked a whole lot of questions. Some of the questions that I'm asking now, did you actually look at the adverse of hazardous environments? Now you're probably thinking it's guidance note, doesn't matter. Okay, so electricity at work regulations. Regulation 5. Strength and capability of electrical equipment is Regulation 5. Regulation 6, adverse or hazardous environments. So in Regulation 5, if I open up Regulation 5 and I read it out for you, because it's quite an interesting regulation, if you can ever call these things interesting, and it quite clearly states, no electrical equipment shall, so there's the statutory word, be put into use where its strength and capability may be exceeded in such a way it may give rise to danger. Well, an electrical installation can only have strength and capability if you're correctly designing it for the external influences. And it then says the defence regulation is available in this proceeding. So it's a shall. Electricity at Work Reg has a shall, and it means it's statutory, you will do it. And there is a defence clause as well. So that's Regulation 5. Now, sparks aren't taught much about Regulation 5. It's normally 12 to 15. Worth noting here that Regulation 16 is competence. The word competence was removed predominantly from the wiring regs because it's a statutory requirement of electricity at work regs. Persons will be competent. Now, you may not think you're the designer, but under the wiring regulations, you are, section 132. Regulation 6. These, honestly, Chapter 13, it maps to EAWR. Adverse or hazardous environments. Electrical equipment which may reasonably, foreseeably be exposed to mechanical damage. The effects of weather, natural hazards, temperature or pressure, the effects of wet, dirty, dusty or corrosive environments, or any flammable substances shall be of such construction or as necessary protected as to prevent, so far as reasonably practicable, danger arising from such exposure. So it's a balance of, you will do something, but it's because it uses the term reasonably practicable, which is a balance of time and cost, it's proportionate to the cost. If you want it to last, and the client wants it to last, when you're in a coastal environment, you will use stainless or GRP. If you don't want it to last and you want to go cheap, then you should really be informing the client or the person ordering the works that the fixed electrical installation may not have the life expectancy or may not perform the way they want. Now that then comes down to them and their decision. At least you've done your due diligence. Now, I'm going to finish off now because I'm really boring you probably, but just as a last thought process, if you're an apprentice or a learner and you want to understand how to really learn and grip the wiring regulations, Chapter 13 is 6 pages long. I would suggest it may be an idea that you look at each clause, not all of them, the one that defines power and voltage, but look at them and see if you can map it to an electricity at work regulation, like what we just have here. Because the regulations that I've just read out to you now, straight away, you can map to regulation 5 and 6. So 13251, design shall take into account environmental conditions. So that regulation, it directly maps to regulation 6 of electricity at work regulation. So you can see there is a hierarchy of you must, you shall, you will. Now, I'm going to leave you at this, but I'm just going to remind you of regulation 29, which is the one regulation of EIW you should remember, because it states, in any proceeding for an offence consisting of a contravention of regulation 4, 5, 8, 9, 10, 11, 12, 13, 14, 15 and 16, please note that number 6 isn't in there because 6 is a balance of cost, but 5 is mandatory. It shall be a defence for any person to prove they took all reasonable steps and exercised all due diligence to avoid the commission of that offence. Very clinically, what that is saying is if you're not undertaking due diligence and you're not taking all steps, i.e. emailing and telling the client that when selecting and erecting the installation it has to consider, even if you're not the designer and the design has been given to you, tell them this is an alternative, this will allow you to meet the electricity at work regulations. Guys, I can tell you now, and girls, if you worked on a job and you turn around to your clients and said, you're asking us to put galv trunking outside on a roof, galv basket, and it doesn't have adequate protection or coatings, it should be stainless or GRP. Please note that under our duty of care, under Electricity at Work Regulations 29, 5 and 6, we are informing you that we believe the design to be incorrect and we would propose the following. There's a very high chance that you will get an instruction or a variation to fix or alter the design to ensure it is suitable and sufficient. When clients see a contractor discharging their duty of care and taking all reasonable steps, as it says in legislation, to avoid the commissioning of any offences or premature failures, it's amazing what a motivator it is to the clients. So there you go, that's my little whistle-stop tour on Chapter 13, Just External Influences in Appendix 5. Please go away and read it. I hope this hasn't put you into a coma, but we will see you on some more snippets, one-to-ones, talking about other subjects. Please get in touch. We're on Twitter, Instagram, LinkedIn, Facebook, and everything else. Or message one of the founder members of E5 as to content you might want to hear. Until the next time, thanks for listening.